I'm going to invite Todd Sharp up. So he's going to come up and give you an example of just how easy it is to build one of these intelligent cloud-native applications in practice. So Todd's one of our top developer advocates. He's super passionate about emerging technologies. And the app that he's built is one he did for himself, kind of near and dear to his heart. He'll tell you the story. But Todd, I'd like to invite you out, and you can take it away.
Thank you, Greg. I appreciate it. What's up, Code One?
Nice shirt!
We're going to look at some really cool stuff today. But to give you a little background and context to this demo, I'd like to share a personal story, if that's OK. Before I do that, let me tell you a little bit about myself. As Greg said, I am a developer advocate for cloud and autonomous database here at Oracle. I live in the mountains of North Georgia. With my beautiful wife of 17 years, my 13-year-old daughter, my 12-year-old son, a potbelly pig named Milton, 6 chickens, a dog, and a cat. Yeah, I think that's it. Yes, it can be kind of hectic at times, but we really love it, and we wouldn't trade it for the world. So today I'd like to tell you a story about my daughter, Ava. Ava is a typical 13-year-old girl for the most part. She's very smart. She's very mature, really organized. She gets that from her mother. She's involved in all kinds of activities like honors chorus, beta club, poultry judging. She's in archery. She can be kind of quiet and shy around new people, but really when she's around her friends and family, she's like honestly the goofiest, silliest girl you've ever met. But last spring and into summer, she started experiencing various symptoms that really at first seemed kind of unrelated to each other, and kind of just honestly seemed like just normal signs of adolescence at first. Things like being tired all the time, just kind of feeling crummy, always hungry, always thirsty. I mean, you don't think much of this when your teenager tells you that they're hungry all the time, right? Like I said, initially they weren't too concerning, but then she started like getting headaches all the time and complaining of blurry vision. So we started to get a little concerned at that point. It finally came to a point where my wife suspected that something bigger might be going on, so she made an appointment with Ava's doctor. The doctor did some blood tests and called us really quickly and said, hey, you need to get to the hospital. Ava's blood sugar is 475 milligrams per deciliter, which is much higher than the expected about 100 normal range. So that night, Ava was admitted into the hospital down at Children's Hospital of Atlanta, and she was diagnosed with type 1 diabetes. We spent the next 3 days in the hospital getting her blood sugar levels under control, and really the next few months just learning how to manage the disease. We're learning as much as we possibly can about diabetes and how to care for Ava and help her learn what it means to be diabetic and really just kind of listen to what her body is telling her. Most importantly, though, at least to me, we're trying to help her realize that diabetes doesn't define who she is. It's nothing that could have been prevented. It's nobody's fault that she became diabetic. It's just the challenge that she has to deal with now, and one that we really know that she can really overcome. When Ava was much younger, she had this school assignment where her teacher asked their students to write about their hero. And Ava chose me many years ago and created this drawing and wrote this little write-up about me. And it's something that I've kept, I'm sure many parents can relate. This is one of those things that you just keep forever and keep on your desk and just always cherish. But really the truth is, Ava's my hero. On that very first day that we were in the hospital back in July, she grabbed that insulin pen and just administered her own injection. And really ever since that day, she's taken every step that she needs to manage the disease and to continue to live her life as an otherwise healthy and happy teenager. I mean, her strength and just the courage that she's been showing has really inspired me to not let anything stand in my way. Now, she still has ups and downs, she always will, just as you'd expect, but her mother and her brother and I, we're just always going to be there to lift her up and encourage her to keep fighting. Oh, sorry. So what exactly is diabetes? I mean, everyone here has likely heard of it, and no doubt there are definitely people here that are affected by the disease in one way or another, either directly or indirectly. But just to clarify things, let's define it. Type 1 diabetes is an autoimmune disease that basically occurs when a person's pancreas stops producing insulin. And what insulin is a hormone that controls blood sugar levels. So diabetes develops when these beta cells in your pancreas are just destroyed by the body. It says, we don't need these, we're going to destroy these. So the body can no longer produce its own insulin. Diabetes can't be cured, but diabetics can manage the disease through diet, getting regular exercise, and receiving insulin. Now, every diabetic is different, but a typical day in the life of a diabetic might involve blood sugar levels being constantly monitored throughout the day. Now, many diabetics accomplish this via a little glucose meter like this that measures your blood sugar levels via a finger prick that's put onto a test strip. This happens at a minimum of 6 times a day. A lot of times, more often than that, 8, 10, 12 times a day, every single day. Diabetics must count carbohydrates at every single meal and at most snacks. Now, it's really important to be as accurate as possible when doing this because they use this carbohydrate data along with their blood sugar levels to perform a calculation to determine the amount of insulin they need based on a personalized formula. And this formula may differ for every single meal of the day. Once the insulin dose is calculated, it's administered via injection with a needle or pen. And finally, diabetics have to be aware of and manage unexpected lows and highs throughout the day. Now, this routine is a reality for millions of diabetics. Every single day, without breaks, without any cheat days, no matter what, just to stay alive. Now, thankfully, technology has come a long way as it relates to diabetes management. If the diabetic is lucky enough to have the insurance coverage or to be able to afford these things, they may have the option to use continuous glucose monitors. These track glucose levels throughout the day via a tiny sensor wire that's inserted just below the skin. And they transmit those levels to a receiver or a smart device via Bluetooth, and they can share data via the cloud. Now, a CGM is often hidden by clothing, and so then obviously it's more discreet than manual monitoring. And honestly, nobody's going to suspect that a teenager that's looking at their phone is going to be checking their blood sugar level, right? I mean, they're probably texting a friend or something. Insulin pumps. Now, these deliver insulin doses, both constant and on demand, via a tiny tube that's inserted just below the skin. They provide a more reliable stream of insulin and are also more discreet than manual injections. They can also be controlled via smartphones and share data via the cloud. Artificial pancreas systems. To overly simplify things, an artificial pancreas is a system of hardware and software, CGM and a pump, that work together to deliver insulin as needed to keep blood sugar levels stable. Now, all this technology can be life-changing for a diabetic by enabling them to spend much less time managing their diabetes and allowing them to focus their time and efforts on things other than diabetes. Now, as amazing as all this technology is, due to cost and other limitations, they simply aren't available or feasible for all patients. So what's missing? Well, with or without the technology, every diabetic must manually calculate their carbohydrate consumption and enter that value into an app or device to calculate their insulin dosage. This can be time-consuming and error-prone, which could lead to an under or overdose. And that's something that could really be devastating to a diabetic. And that's why I decided to build something to help simplify the process and increase the accuracy of carb counting. Let's take a look at a demo of the system that I built. All right. Okay, so let me make sure I'm connected here. It probably timed out as I was waiting in the back. Excellent. Okay, so everyone can see that? Great. So what we have here on the right side of the screen is the app running on my mobile device, and on the left side of the screen is just a camera I have set up on the table here. And I want to walk you through how to use the app. So what you see at the very top there is basically a mode selection buttons. And I built two modes, both a full mode and a quick mode. Full mode being including an insulin calculation, and quick mode if we just wanted to check the carbs in a certain piece of food and we didn't want to perform an insulin calculation. Below that, you can see all the various formulas. As I said, each diabetic has personalized formulas that sometimes differ throughout the day. So in this case, we have some different formulas set up. We'll go ahead and select lunch as the formula we use for the demo. And then at the bottom, we can choose a capture mode. We can either use a picture or a voice. Let's start off using a picture. So the next step here is the app's asking us what we're eating. And so at this point, we simply take a picture of whatever we're eating. So in this case, we'll take a picture of an apple. And we'll get that uploading. So let me get that out of the way here and bring in this guy. And what we have here is a Bluetooth digital scale. And at this point, the app's going to ask us to weigh the portion. So we take our apple. I've already paired the Bluetooth scale to the app, so I don't have to do that for this demo. But at this point, we simply put the apple on the scale, and it weighs the apple for us and updates the app in real time. So the next thing I'm going to do is accept that weight, so I'll just click the check button. At this point, the app is asking us to confirm what we're eating. It's identified that we're eating an apple, so we have a list of foods here to choose from, and we can, at this point, can choose apple raw. And the next step it's going to ask us is if we're eating anything else. So assuming, like I said, we're eating lunch, probably stands to reason that there'd be some kind of snack with lunch. So we have some graham cracker sticks here, so we'll say yes. And we will take a picture of the graham cracker sticks. Trying to get the glare off of that. There we go. I think that picture will hopefully work. And we'll pull the scale back over. Conference Wi-Fi is a little slow when uploading, of course. And there we go. So now we're going to weigh our Scooby snacks. As you can see, I'm not sure how well you can see it. It says 28 grams. The app's reporting 27.9, pretty close. We'll go ahead and confirm that. And it says which one of these best describes your food. Our first choice is Keebler Scooby-Doo Graham Cracker Sticks Cinnamon. Looks like what we're eating, so we'll confirm that. And the next step is we're going to go ahead and add one more thing to the meal. And in this case, we're going to add a peanut butter sandwich. Now, it would probably be pretty difficult to use image recognition to identify a peanut butter sandwich. It could probably guess sandwich, but it would probably have a real hard time guessing what's inside of that sandwich. It could be bologna or ham salad. So in this case, we're going to use our voice instead. So we switch over to the voice input screen, and we click the microphone. Peanut butter sandwich. All right, so it's taken my speech and converted it to text. We'll confirm that. We'll bring our scale back over here. We'll weigh our sandwich. 72 grams, sounds good. It asks us to confirm that it's heard us correctly. peanut butter sandwich. And at this point, it's asking if we'd like to add another food. Well, no, I think a sandwich and an apple and some graham cracker sticks is a good lunch, so we're going to say no. The next step in the process here will be to check our blood sugar. Because as I said, not only do they need to count the carbs, but they also have to determine their blood sugar to determine their insulin dose. So at this point, we'll take this Contour glucose meter, we'll turn it on. And once it's turned on, we will pair it with the app. And it says our current blood sugar is 100, right? Because it read the app via Bluetooth, read the glucose meter from Bluetooth. This is my own blood sugar. I tested it a few nights ago. So obviously, I'm not being diabetic. I'm at about 100. So at this point, we've input all our foods, we've confirmed them, and we've uploaded our blood sugar. And the next step here is going to be to get a summary of our inputs. So if we click the check button now, we come to the summary screen, and it says, since your blood glucose is currently 100, you'll need a correction dose of 2 units of insulin based on your lunch formula. Your carb coverage is as follows. Apple, 192 grams, that's 26 grams of carbs, 2.21 units of insulin. The graham cracker sticks, we're at 20 carbs, and so on and so forth down the list of all the foods that we've identified. And at the bottom, we have a summary of our total insulin dose of 8.45 units. We can save this meal by clicking the checkbox. And on the next screen, it tells us that based on the data you've provided, your next glucose reading is predicted to be 108 milligrams per deciliter. At this point, we click the checkbox, and we're done. Thank you. So let's take being a developer, and since this is Code 1, let's take a quick look at the architecture. At the heart of the system is a progressive web application, and that's what you just saw. The app can be installed and run on a laptop, desktop, or mobile device, and it's backed by 3 different microservices, all deployed as Docker containers in a Kubernetes cluster within Oracle Cloud. Having clicker problems today, and I apologize for that. This is probably why they want me to use their clicker. All right. Try it again. The user service stores information like target ranges and profile data in an autonomous DB instance, in this case, autonomous transaction processing. This instance is shared across all 3 microservices. Each of them have a distinct schema within that. I could have used separate instances if I wanted to, but just to keep things simple, I used the single autonomous instance. The user service is a Helidon SE Java microservice that handles persistence via Oracle REST data services, which is also known as ORDS. If you're not familiar with ORDS, it's a really awesome open source service that we offer. And I'd basically describe it as a way to get data in and out of Oracle DB using REST instead of SQL. It's really easy to configure, and it just gives you a simple API for persistence and querying. The next microservice is the formula service, and it's written as a Node.js microservice using the Express framework. Now, this service handles the persistence operations for the user-specific formulas that are used in calculating the insulin dosages. And for this service, I decided to store the data as JSON documents in Autonomous DB using SODA. And SODA stands for Simple Oracle Data Access. SODA is basically a set of NoSQL-style APIs that let you create and store collections of JSON documents in Oracle DB. You don't need to know SQL. You don't need to know how they're stored in the database. It just handles all that for you. The final microservice is the nutrition service. Now, this service is also powered by Java, but this time it uses the Micronaut framework. And for persistence, it uses Micronaut Data JDBC. Micronaut Data is this, it's a data access toolkit that uses AOT compilation, just like Micronaut, the framework does, to pre-compute queries for a repository interface that are then executed by this just really thin layer at runtime. Now, the nutrition service also provides an endpoint for image upload and also interacts with the USDA's Food Data Central API for nutrition information. Now, it's interesting to note that across all three of these microservices, there's only one SQL query used, thanks to ORDS and SODA and Micronaut data. A little more on that query later. Let's take a look at the food identification process in a little more detail. So how's the food actually identified? Well, as you saw in the demo, you can input foods via photo or voice, and depending on which method's chosen, something a little different happens on the back end. If a photo is used for food identification, it's uploaded to object storage, and a configured cloud event fires, which triggers a serverless function. So as you saw in Greg's talk, an FN serverless function. The serverless function performs the calls to several third-party APIs to perform the OCR and image recognition, and the results are published to a stream using Oracle Streaming Service. The nutrition microservice subscribes to that stream and posts the incoming message to a server-sent event endpoint that the PWA client subscribes to. This enables the results to be pushed in real time to the connected client without the need for polling or socket connections. Now this provides the front end with the image recognition concepts or the text that is extracted directly from the image, and that's used in the next step. The next step is to grab the nutrition information. If an image concept is identified, for example, like when we saw the apple, if the image recognition identifies a concept, but there's no text extracted, then the concept with the highest confidence value is used as a keyword for a search of the USDA's Food Data Central API, and that returns a list of potential foods. Now, of course, you can override that concept if the image recognition process wasn't perfect. But if the image did contain text, then that text, as in the case of the graham cracker sticks, is what's used as the basis of the query. The user then selects the food from the list of foods returned from the API, and the detailed nutritional information is retrieved, again, from Food Data Central. Now let's look now at how the next glucose reading is predicted. And for this, I used Oracle Machine Learning notebooks to construct and train a model for my predictions. Now, these notebooks are freely available with all Autonomous DB instances. It's kind of hard to see what's going on here, but essentially what happens in step one is that I use a query to create a single unified view of all the data that's going to be used to train the model. Now, to me, the beauty of this query is that even though I've stored the data in 3 distinct schemas, sometimes in a different model altogether, like JSON, as in the formula service, I still have the ability to combine all of the data in a familiar tabular view format via simple queries like this. Now, in this case, like I said, I combined the user data, the profile data, and the nutrition and meal data into a single materialized view. Next, we create our model. Now, I've chosen linear regression as the mining function here, but we offer many, many options as far as the algorithms that are available to you. That's just the one I happen to choose. The next step is to create our train and test data sets. We use a sample from the combined materialized view from step one to train, and the remainder of the data to test the model. Next, I make predictions against the test data with upper and lower bounds to determine the accuracy. And finally, I finish with the only SQL query used within the entire architecture, and that's the query that predicts the next glucose reading based on the inputs provided from the current meal. Now, I really believe what I've created in just a few short weeks can really be developed into something that makes carbohydrate counting much easier for many diabetics, especially those who are younger or maybe newly diagnosed. And while that's truly important, what I'd like to leave you with today is this. Everyone here in this room and those watching online have a really unique set of talents and skills and abilities. And we're living in the age of amazing technology, As you saw in Dr. Bourne's talk earlier, just access that we have is just amazing. Things like AI and ML are already doing so much to improve the lives of so many people with needs. But my challenge to you is this. Find something that is important to you, something that you're truly passionate about. Maybe it's something that affects you directly, or maybe it's something that affects someone you love. Maybe it affects total strangers. It really doesn't matter. But take advantage of the technology we have available and use your skills and abilities to do something to improve the lives of those affected by it. Let's do more than just build software for ERP or e-commerce. I mean, those things are great. Don't get me wrong, they put food on our tables. But let's do something to make this world a better place. Thank you. Next up, please welcome the lovely Maria Colgan. Thank you.
Wow, what an awesome demo. Hopefully you're inspired to make this world a better place. But what I'd like to do before we rush off and do that is explain how Todd was able to so easily store both unstructured and structured data and then process that data by taking advantage of the Oracle Autonomous Database. Now, that Oracle Autonomous Database is a new set of cloud services that are self-driving. That means that we'll automatically provision, manage, and monitor all of the infrastructure you need for that database, as well as the database itself. We'll make sure that it's perfectly safe by preventing any kind of external attack, as well as any malicious internal user that may be trying to get up to no good in your database. We also want to make sure that it's fully protected from any potential downtime. So we'll give you a highly available architecture as well as disaster recovery. Now, as Todd mentioned, he was able to use the Autonomous Database to store both his JSON documents, or his unstructured data, and his relational data, and then be able to join those data sets together. And regardless of what kind of language you want to use to interact with that database, you can do so with the Oracle Autonomous Database. So all the usual suspects, whether it's SQL, PL SQL, if you want to use Python, Node.js, .NET, whatever it may be, you can use all of those languages with it. Now, you can see there on the slide behind me all the different capabilities the Oracle Autonomous Database has, but rather than talking you through them all, I thought it would be great if we could take an opportunity to show you the Autonomous Database in action. So the first thing when you are starting a new project is we need to provision that infrastructure and that Oracle database. And oftentimes this can be kind of the long edge of the project as we wait for all of that to be deployed. And what I'm going to show you now is that we can deploy an autonomous database in just 2 minutes. So we're going to start that by logging into the OCI console. I can take one of the cheat shortcuts there, but I'm going to go the long way through the hamburger menu and pick the autonomous database off the list. Once I'm there, what I'm going to do is I'm actually going to change my region, so we're closer here to the Moscone. I'll go to the West region, and then I'm going to ask it to create an autonomous database for me. That opens a simple form, and I need to answer 5 or 6 short questions. First, it wants to know what name I want to give it, so I'm going to call it mine Swingbench ATP, because that's the workload I'm going to run against the database in just a minute. Next, once I've got the display name, it needs a database name. I'm going to use the same one. I'm not very imaginative. It's late after all in the afternoon. Next, I get to decide what type of workload I want. Am I going to be a data warehouse or transaction processing? I'm going to pick transaction processing, and I'm going to make sure that I get the serverless one where I don't worry about anything at all. Now I get to pick what resources I want for that database. You can have anywhere from 1 to 128 CPUs. I'm going to have 2. And the same with the storage, anywhere from 1 to 128 terabytes. Again, I'm going to just go with 1. I could enable auto-scaling at this point to let Oracle scale it for me, but I'm going to show you how to do it manually later, so let's not do that. Next, I need to give it an admin password. You see there in red, Oracle specifies a bunch of rules that your passwords must meet. Once my password meets those, though, it disappears. Last, I need to decide on the license. Am I going to bring my own license or pay for a license as part of the service? I work for Oracle, so I'm just going to bring mine. And with that, it will instantly begin to provision that autonomous database for me. And what it'll do is open a new console that shows me all the information and all the controls I have for that autonomous database, whether I want to stop it, start it, scale it up. You see there information about the decisions I made when I began to provision that system. And at the bottom of the screen, you'll see information about backups. Your autonomous database will be automatically backed up on a nightly basis for you, and we'll keep 60 days worth of backups automatically for you. You can also take a manual backup, so if you're making changes to the application and you want to be able to fall back, you can. And with that, I have an autonomous database, so that's pretty neat. Now, once I've got that database, I want to be able to connect to it. And with the Oracle Autonomous Database, you're going to get 5 predefined services that are going to help automate your workload prioritization. Each service has a different priority, so my mission-critical workloads can come in on that highest priority service. In this case, that would be TP Urgent. But if I'm running also analytics, maybe I'm running some reporting on that same system, I can have those queries come in at a lower priority service so that they don't interfere with the online users. I can also have some of that batch reporting run in parallel if I wish by using the appropriate service for parallelism. Once I begin to develop my application, one of the things that I might want help with is actually tuning or optimizing the database for that particular workload. And with the autonomous database, I'm going to get automatic indexing built in. And what that is an expert system that's going to monitor the workload. So as I begin to develop the application, I begin to issue queries against that database, it's going to monitor that workload for me, determine if there are any missing indexes from my schema, and then it will verify that if those missing indexes were present, that they would actually improve the performance of that application. So they would actually be able to speed things up. Once it's identified those indexes and verified that they do improve performance, it'll automatically publish those indexes to the application, and it can begin to use them and take advantage, excuse me, of that faster access method. Again, all of this happens automatically. You don't need to do anything in order for this to take place. It will just do it for it. And as your application evolves, let's imagine at the beginning we were going after certain data that actually we decided wasn't that important, and we've changed the queries over time. Automatic indexing goes in and cleans up after itself. So if an index it has created is no longer necessary, then it will just remove that index as well, making sure that we don't just bloat your database for you. Now, one of the things we touched on when we were provisioning our autonomous database was scaling that system. And with the Oracle Autonomous Database, there's really no rules around the scaling. You're free to scale either the CPU, the storage, completely independent of one another. So there's no fixed shapes that you have to adhere to, because no two applications are really identical. Oftentimes, some need more storage, while others may need more CPU, or you can scale both together. You can also take advantage of our auto-scaling, where you want Oracle to automatically scale up the resources for the system based on your workload. So you define a base CPU count, and then as your workload increases and you begin to max out that CPU, auto-scaling will increase the number of processors on that system automatically for you up to 3x that base number. And once the workload goes down again, we'll automatically scale you back to that base, allowing you to truly only pay for the resources you need when you need them. So how does that scaling work? Well, what I'm going to do is I'm going to run a swing bench workload here. I'm going to connect 128 users to my autonomous database. They're processing JSON documents, so inserting, updating, and retrieving JSON documents. And the fourth column there is the one that you're interested in. That's going to show you the transactions per second on this workload. So all 128 users are connected. And if you look at my transaction rate, you'll realize it's quite erratic, which is an indication that perhaps I may have overloaded my autonomous database. Remember, I only have 2 CPUs on that database. And so if I look at the database monitor to see what's going on, I realize I'm completely CPU bound, and the scheduler is working overtime trying to schedule all of my processes. So let's give it a hand. I'm going to go back over to the OCI console, and I'm going to scale it up. And I'm going to change it from the original 2 CPUs to 8. So again, could have the option to do auto scaling, but I won't. I'm going to continue to do it manually. And what you'll see there is instantly it'll begin to provision those additional CPUs for me. Now, if we go back over to Swing Bench, we'll be able to see that change take place. Now, it'll take a couple of seconds, about 20 to 30 seconds, for those additional CPUs to come online. So if you look at the monitor, if you can see it closely there, there's a dotted green line that indicates the CPU count. There it goes. It jumps up from 2 to 8. So we now have all 8 CPUs available to the service. And if you look at the fourth column across in the background there, my transactions per second is much more consistent now. I'm getting a consistent 32,000 transactions a second on my workload now that I've scaled the system up, which makes it nice and easy for me. Once I've got my development environment up and running, I may want to share it. Oftentimes, we're asked to clone dev environments. Maybe it's so that people can begin testing the application, or simply to allow a colleague to participate in it. And with the Oracle Autonomous Database, we make it incredibly easy for you to be able to do that by allowing you to clone that autonomous database and get a point-in-time copy of that database for a colleague or for that test environment. When it comes to cloning, you get 2 options. You can do a full database clone, one where you get all of the data and all of the metadata in the existing autonomous database over in the copy, or we can just copy the metadata. So the copy would have the exact same schema, the same users, but none of the data from production in it. You get that choice. It's super easy to clone. I'm going to show you an example right now, because all I've got to do is answer 4 simple questions, and it will automatically provision that clone for me. So here we are back on my database with the 8 CPUs and the 1 terabyte worth of storage. I'm going to create a clone, and as I said, your first choice is, do you want a full clone or a metadata-only clone? I'm going to go with a full clone. I want to give the developers all of the data, not just the metadata. Once I've made that choice, I'm going to scroll down, and it's already given me a default name for my clone, but I'm going to call it something a little more unique. I'm going to call mine SwingBench 2. I need to give it a new database name because it is a separate database, so I'm going to call it SwingBench ATP 2. And then I get to decide, do I want to give that clone the same resources I had on my original environment or not? And this time, I'm not going to give it the same resources. I'm only going to give it 2 CPUs, but I am going to enable auto-scaling for it. I need to give the clone a new password. Same password rules apply. Once I've confirmed that password, again, I make a decision about licensing. I'm just going to bring my own. And straight away, I got brought into the clone UI now. So I'm inside the clone. You see the same general information about the clone as we had for the original database. And if I go out to the higher level view, you see there now I have 2 autonomous databases. The original autonomous database that we had, that's highly available, or sorry, currently available, and has 8 CPUs, and the clone that's currently provisioning with just 2 CPUs. If we go back in there, you'll see I have enabled auto-scaling for that clone, so it will actually be able to use all the way up to 6 CPUs. Oh, there it is. Now the clone is available. And just like my original database, that clone is a multi-model database, so it will be able to do structured, unstructured data, traditional transaction processing or analytics, as well as perhaps some of the newer generation type of applications, whether that's machine learning, as you saw Todd use, whether you're doing it as part of a big data environment, or perhaps as microservices. Autonomous databases make great databases for microservices. Regardless of what you're doing, you can do it with no risk and no compromise, because you're getting an autonomous database on the best platform for the Oracle database, which of course is Exadata, and you'll have all the scalability, availability, and security you're going to need for that project. Not only do you get all of that goodness with the Oracle Autonomous Database, but right out of the box with it, you're going to get a number of development tools to make it easier for you to get started with new projects. You're going to get SQL Developer Web, which has all the goodness of the Oracle SQL Developer desktop tool in a web browser. So I'm able to execute SQL, PL SQL through that. I'm able to build out my data models through their modeler capabilities. And I'm also able to monitor and manage that database through the SQL Developer Web. I'm also going to get an Apex environment. Apex is a web-based, low-code application development environment that it comes out of the box with your autonomous database. That way, all of your development can all happen within the browser and then have it instantly deploy against our autonomous database. We also allow you the ability to REST enable that autonomous database. So you can REST enable a schema and automatically generate REST endpoints for the tables and views within that schema, allowing your application to be much easier and simpler to deploy by simply making REST calls instead of having to write all of the SQL in the application. So let me quickly show you where you can find all of these tools. In the Service Console, you saw Todd go here earlier. Under the Development tab, there you see direct links to the Apex environment, the SQL Dev Web, the ML notebook that Todd used. I'm going to go into SQL Dev Web first. Here I'm going to log in using the admin user and the password I used when I created the autonomous database. Once I'm in, I'm there in the SQL worksheet where I can write any SQL. I also have a Home tab, which gives me information on the other activities I've already done in this environment. Or I can go into Data Modeler. And you'll notice when I go into Data Modeler, there's a little tour there that I can take to help you navigate through it if you wish. Now, I'm not going to do that right now. I'm going to create a user so I can get going on a new Apex application. So I'm going to go ahead, create that user, and grant it all of the necessary privileges it's going to need to be able to build the app that I want. So you see there at the bottom of the screen, you can see the results of that script output. I've got my user, so I'm going to go back over now and go into Apex. Again, I'm going to log in initially as the admin user, and I'm going to create a new workspace for the user I just created, so for my Apex dev. Now, you see, I could have created the user here as part of that screen, but I wanted to show you SQL Dev Web. But now that I have the workspace, I can begin creating a new application, and I can create additional workspaces as well. And it's not just the database that Oracle has turned into an autonomous database. You would have heard yesterday from Mr. Ellison all about Oracle Autonomous Linux, which allows us to automate the entire OS lifecycle for you so that you can stay current, because we're going to automatically patch and tune and look after that operating system for you, allowing you to be able to develop much faster without requiring any downtime in order to allow IT to patch your environments, and then requiring you to double check after the patch that everything has come back up correctly. We'll do it all online, fully automatic for you, so that you're always in a reliable and secure environment, but you're not suffering any kind of downtime in order to create such an environment. With that, I want to thank you all for joining me, and I want to strongly encourage you to take advantage of the new free tier that we have. Remember, you're going to get 2 autonomous databases as part of that free tier. You also have, remember, a special 30-day free trial just for being an attendee here at Code One. And again, I urge you to take advantage of that. And with that, I'd just like to thank you on behalf of myself and all the other speakers here today, and we hope you enjoy the rest of the show. Thank you very much.